Suppose we want to find the area of a sector of a circle. So not the entire circle, just part of a circle. So think slice of pie, slice of pizza, something like that. Well, we know from past experience that there are 2 pi radians in an entire circle. An entire circle, we can find the area of the whole thing. You've probably seen at some point in your geometry past, the area of a circle is pi times the square of the radius, pi r squared. But I don't necessarily want the area of the entire circle. I only want the area of this piece of it. So I have this central angle theta, not the whole thing, not the whole 2 pi, but only theta of it. And I want to know what's the area of just this part, not the entire circle. So I just want to know what's the area of this piece. Well, proportional, not so different from arc length. The ratios are the same, even though the numbers are different, the ratios are the same. So this is a proportion here. And we can simplify a little bit before we even start. I can divide pi and pi right there. Cross multiply, top of one times the bottom of the other. So I have 2 times a and theta times r squared. Oh, almost there. The goal was to find the area of the sector. So we have theta times r squared divided by 2. You don't have to remember anything that we don't have to remember where it came from. I'm not going to ask you to reproduce that or anything like that. I just do that because mathematics is magical, but it is not magic. Sometimes if I just hand you a formula, it feels like magic, but it comes from stuff we already know. So there's how we're going to find the area of a sector of a circle. As with arc length, it is critically important that theta is in radians. This whole setup, theta was in radians, theta has to be in radians. If it's not, fix it so it is. And then go on with your life after that. Let's see, if I want to know the area, well, really, I probably want to know the volume. Depends how high the pi is, but we're just thinking of the area, like the area of the top of this slight 30-degree slice of an 8-inch diameter pie. If my pie is 8-inch diameter, that means it's radius 4. If my slice is 30 degrees, you can convert that to radians. We can't use it as 30 degrees but to change it. So 30 degrees is pi over 6 radians. If you remember that, that's wonderful. If you don't, change it by multiplying by pi over 180. And now we're ready. That's all the information we need. The area of this slice of pie is theta times r squared divided by 2, which, let's see, that's 16 divided by 12, and the pi is still in there, is 4 pi over 3 would be our exact answer. That's not necessarily, I relate to that very well, so I'm going to find out what is 4 pi over 3. Got my handy dandy calculator right here, is about 4.2 square inches. We're talking about area, so we're measuring in square units. We were in inches, so now we're in square inches. So that's about we're going to go 4.19 square inches. That's our approximation for the area of this slice of pie.